Hi my dear students, welcome back to the class. Today we are going to begin the journey to the plus 1 plus 2 life, right? So in this class we are going to start a very interesting lesson and the very first step to the journey, and the name of the chapter is nothing but sets of your mathematics NCERT textbook. This is a very interesting chapter and very easy chapter to learn. Of course, this chapter ensures you a lot of mark in examination. So we shall begin it. The name set itself defines something, right? You may have used the word so many times in your everyday life, right? Like the set of books, the set of pens, etc. Or even the set of natural numbers in your mathematics classroom, right? You use this term called set in various contexts, right? In this class, we are going to redefine the concept of set. So, in this class, we are going to define what is a set, and also we are going to reconstruct the already existing concept about the term set. Do you know what does the very basic definition of a set? It is nothing but a well-defined collection of objects. This is the basic definition, or this is the definition we give to the term sets. So basically sets can be defined as nothing but a well-defined collection of objects. But the problem is how we understood this, or how we can interpret this definition. Lot of people just consider anything which is a collection as set. This is absolutely wrong. This is not the thing which we have to interpret from the basic definition. See, the definition is, we can write the definition as sets are nothing but a well-defined collection of objects. See, we defined sets are nothing but well-defined collection of objects. But the problem is we have to understand each term in this definition very well in order to interpret the term set very well. See, first term is well-defined, and first part is well-defined, and the second part is collection of objects. We shall examine each part of this definition in separate. First of all, collection of objects. Of course, you know this is the very basic concept underlying the term sets. It must be a collection of objects, like the collection of pens, the collection of books, or the collection of bottles, anything, collection of balls, collection of bats, anything. If it is a collection, we can basically say it as a set. So basically a set means nothing but a collection of objects. See, natural numbers, if we list out the natural numbers from 1 to 10, it is basically a collection, right? The natural numbers from 1 to 10, right? Similarly, anything which is a collection of objects is basically set, or sets are basically collection of objects. But there is another restriction too. What is that? It must be well defined. The problem lies here. What is well defined? We shall examine what is a well defined collection of objects. So in order to examine or understand the definition of set very well, we have to understand the difference between what is a well defined collection and what is a not well defined collection. So if we have a clear understanding about this difference very well, then it is easier for us to understand any set, or it is easier for us to recognize any collection of objects as a set and non-sets. Okay, now let us look into some example. Here I have provided two sets, namely set A and set B. And the problem here is, in each collection I have listed several examples. Now we shall look which is a well-defined collection and which is not. Okay, the first question, odd natural numbers less than 10. Of course, it is very well. 1, 2, 3. Odd natural numbers. So 1, 3, 5, 7, 9, which will be the set of odd natural numbers less than 10, or the collection of odd natural numbers less than 10. Now the question is it a well-defined collection or not? We can solve it very easily. See, the first question in the second collection is 3 best Indian cricketers. For me, it is Sachin, Dravid and Kapil Dev. And maybe for you, it may be Sachin, Kohli and Dhoni. And for someone else, it may be another 3 sets, 3 players, and similarly, it can vary according to person or according to the psychology of the person. The answer here will be a varied collection, right? So, in this case, the question or the collection obtained is objective, which means that it will not vary from person to person or country to country, or it will be the same everywhere. So we can say that this is a well-defined collection. So this collection is well-defined, whereas this is a subjective collection, because that it will change from person to person. According to the psychology or the mentality of the person, the answer obtained here will be a different collection in each and every situation. So we cannot say that this is a well-defined collection. We cannot say this is a well-defined collection. So this is not well-defined. Similarly, observe that the rivers of India. Of course, you know the rivers of India, and the answer or the collection obtained as the answer of this statement will be the same for everyone, for every country, for every community. This will be the same. This will result in a same collection of object. Whereas 5 beautiful flowers, of course it is a subjective statement, and the answer obtained here or the 5 flowers in this collection will be a varied collection from person to person. So this is also not well defined collection, whereas this is a well defined collection. Similarly, all other 3 examples in the first collection is well defined, whereas all the 3 examples in the second collection, the collection B, is not well defined, because the collection here or the statements here will result in an answer which is not well defined, which means that it can change from person to person or from country to country, or it will be a varying collection. It is not a consistent collection or a constant collection, but here the answer is or the collection obtained is always still consistent, and it is a constant collection. It will not vary according to person or country to country or anything. Cannot change this. This is always fixed collection, which means that the definition set. The definition set means a well-defined collection of objects, which means that the collection in the definition must be a consistent collection. It should not change according to person or country to country or religion to religion. It must not change. It should remain the same always. Such collections are called sets in this chapter. So in mathematics, we call sets as those collections which are well defined. So I hope you understood what is a well defined collection. Now we shall move on to the next concept. Now the problem is, of course we defined what is a set exactly, and now we know what all things are set and what cannot be a set. So the problem now is how we can represent a set. In mathematics and in the coming sessions all, we will denote set by capital letters. So maybe we denote A as a set, B as a set, C as a set, which means that whenever we denote a set by a capital letter, it means that A is equal to some set, B is equal to some set, C is equal to some well-defined collection of objects. Always note that throughout the entire mathematics in +1 as well as in +2, we always denote the set by a capital letter. You have already done this before. See, you denoted the set of natural numbers by the letter N. Do you remember it? Natural numbers. So you know that the set of natural numbers, the natural number set is a well-defined collection, because it will not change according to person, right? So it is a well-defined collection, so it satisfies our definition of what is a set, and we denote that set by N. Also, do you remember what is Q? Q is a set of rational numbers, right? Do you remember what is R? R is a set of real numbers. All these sets are notated by capital letters. Now what is n plus positive natural numbers, q plus positive rational numbers, r plus positive real numbers, and we denoted z as a set of integers. Do you remember it? This also a fixed collection of objects, well defined collection of objects which will never ever change according to person or country to country or region to region, etc. It will not subject to change. It is an objective set. That's why we denote this by a capital letter. Always remember that when we always represent a well defined collection of objects by capital letters. So in mathematics we are going to denote. These are the some examples of well defined sets. In our previous classes we used natural numbers by n, rational numbers by q, real numbers by r. Now you know why we used these letters to name these sets, because we always use some capital letters to represent set, and we fixed the letter n as the set of natural numbers, letter q as the set of rational numbers, letter r as a set of real numbers, letter z as a set of integers. You know z plus is the positive integers, z minus is the set of negative integers, and so on. So that's it. We can denote, always we can denote the set of any well defined collection by a capital letter. Now we said that we use capital letters to denote sets, right? Capital letters to denote a set. Now we use small letters to denote elements of a set. That means that if capital A is denoted as a set, then we can say that we know that a set is nothing but a well defined collection of objects. Then that collection must have some elements in it, because it is a collection of objects. So those elements are denoted by small letters like A, B, C, D, etc. So small letters means the elements in the set, whereas capital letters means the set itself. So always remember that we use small letters, small English letter alphabets to denote the elements in a set, or the objects in a set, or the members in a set. See, we can use elements, objects, or members as synonyms to terms. So instead of terms we can either use elements or objects or members of the set. So always remember that we use small letters to denote elements of a set, whereas capital letters to denote the entire set. Now suppose that the small letter A is an element of this set, capital A. Then we denote it as A belongs to capital A. We should read it as A belongs to capital A. And suppose that B is not an element of capital A, then we denote it as B does not belongs to capital A. We should read it as B does not belongs to capital A. So in order to denote a member, an element is in the set, we have to denote it as A belongs to. Read this symbol as belongs to, right? Belongs to, and this is as not belongs to. So whenever we have to represent, or we have to say that a point or a number is in a particular set, we can denote it like this. Suppose that A is the set of all first 10 natural numbers, then of course 2 is an element of this set. Then we can denote it as 2 belongs to capital A. Now 11 is not an element of capital A, since A is a set of all first 10 natural numbers. Then we can denote it as 11 does not belongs to capital A. So this is it. We can denote this symbol. We can use this symbol to denote or to notate when the elements in a set, whereas this symbol to notate those things or those numbers or those objects which are not in a particular set. So we now understood that we can use capital English alphabets to represent or to denote a set, whereas small letters to denote those elements, those terms which are in the set, or those terms which belongs to the particular set. Also we can use the notation belongs to notate whether an element is in the set or not in the set. See, we can use either of these two notation, belongs to and not belongs to represent accordingly. Now, there are two important methods to represent a set. Suppose that we have a huge collection of sets, so we have a method to represent a set. The two methods can be named as, the first one is called roster form. Roster form, and the second method is called set builder form. So we shall examine each separately. See, roster form and set builder form are basically two methods to represent any set. So now we shall represent, or we shall examine each method separate. The first method to represent a set is roster form. In roster form, we are usually just listing the entire terms of the set. Suppose that we are provided with a condition or a statement to list the set, then in roster form we are going to represent the set by listing all its terms. Suppose that you are asked to write the natural numbers from 1 to 10. This is a very basic example. Suppose that you are asked to write the natural numbers from 1 to 10, then you have to list every term with commas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the first 10 natural numbers. You have to list each and every natural number separated by commas and enclosed within a curly bracket. See, you have to list every term, list every element of the set by separated by commas, and you have to put it in curly bracket. So this is the way to represent a set in roster form. So this set can be named as a capital letter A, where A is the first 10 natural numbers. Similarly, the second set, you can list out the positive integers Z plus in roster form as what? 1, 2, 3, etc. Just put etc. Then close it by curly bracket. See, this is the set of Z plus. This etc. means you are listing out all the terms, but you are not showing it here. Just putting 3 dots to represent that it is an infinitely many elements here. That's it. So in order to represent any set by roster form, you have to list each and every element of the set separated by commas, and you have to put that list in a curly braces. Now, suppose that you are asked to write, let B be the set of all English vowels. Then you have to put that set in a curly bracket, and you have to list each and every term A, E, I, O, U, and it must be separated by commas. So this is the way to deal with the set in roster form. Always remember that in order to represent a set in roster form, you have to put the set in curly braces, and you have to list each and every term inside it separated by commas. So now we shall discuss how we can represent a set in set builder form. In set builder form, we are stating a property which is only possessed by the set of elements in the set and not by any element outside the set. Suppose that we know that in set builder form or in roster form, we can denote the set of all vowels in English alphabet like this, right? So this is the roster form representation to denote a set, right? This is the roster form. You know this now, right? Roster form. Now coming on to the set builder form, we are stating the single property which is owned by the elements of the set and not by any element outside the set. So this same set can be represented in set builder form as, you have to put that also in the curly bracket, and in the set builder form we denote the same set like this: set of all X such that X is an English vowel in the English alphabet. Sorry, X is a vowel in the English alphabet. English alphabet. Right, see. So this is a set where we represented the same set in the roster form, and the same set can be represented in the set builder form like this. See, here we have stated the single property owned by this set, right? X is a vowel in the English alphabet. See, every element satisfies this property, and any element outside this set doesn't have this property. And also we used the letter, small letter x, to denote any arbitrary member in the set. So x can be either A, x can be either E, x can be either I, or x can be O or U. See, x is the variable used here to represent all the elements of the set. Similarly, you know that the set of all first 10 natural numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, this is the roster form, right? Roster form. Now we can easily represent the same set. Let me name this set as A. The same set A in the set builder form as set of all x such that, always remember that whenever we are writing in the set builder form, we begin like this: set of all x such that, what is x? The property owned by all these elements in the set. X is nothing but x is a natural number less than 10, less than 11, less than 11. See, x is a natural number less than 11. The number, or you can represent the same set like this: set of all x such that x is anyone in the first 10 natural numbers. The two statements represent the same set. So we can represent the same set in the roster form into the set builder form just by stating a property which is owned by only the elements in the set and not by any element outside in the set. See, x is a natural number less than 10, 11. See, only these 10 elements satisfy this property, or x is anyone in the first 10 natural numbers. See, only this set or these elements satisfy this property and not by any element outside this set. So whenever we are representing a set in the roster form, what we are actually doing is we are stating the property which is possessed by only by the elements in the set and not by any element outside the set. Or you can suppose that, let me give you a set builder form, a set in the set builder form: set of all x such that 0 less than x less than 5 and x is a natural number. See, x belongs to n. This is also a roster set builder form because we have stated a property which is satisfied by only by the elements in this set. See, x element of n, this should be read as element of or belongs to n, which means that x is a natural number. X belongs to n because n represent the set of all natural numbers. X belongs to n, thus represent the terms in the set of all natural numbers. That is, x is a natural number. Also, x must satisfy 0 less than x less than 5. So we have stated a property of the variable x to be in the set A. Now we can easily represent it in the roster form also. What is the property satisfied here? 0 less than x less than 5 and x must be a natural number. Which are the natural numbers there? 1, 2, 3, 4. See, this is the roster form representation of the same set. So we can represent a set in either in the roster form or in the set builder form. In the roster form, what we are actually doing is we are listing out all the possible members in the set. Whereas in the set builder form, see the name set builder, which means that we can build the entire set from that property. Here we are given with a property 0 less than x less than 5 and we build the entire set from this single property. Similarly, suppose that, what is the use of set builder form? You can minimize the space. Suppose that you are given with a set in the set builder form like this: set of all x such that 0 less than x less than 10,000 and x element of z. See, Here we have to, in order to represent the set in the roster form, we have to represent or we have to list 10,000 integers, isn't it? Which is a huge and very time consuming process. But this form represents the same set in a minimal space, right? This saves our energy, time and space. So set builder form has its own advantages also. Now you know what is the exact difference between a set builder form and a roster form. Why it is called a set builder form? Because we can easily build the entire set from that single property. Here we builded the set from this single property. Here we can see if this is a set builder form, similarly reverse we can build this entire set. If this is a set builder form, we can always, it is possible for us to build the entire set just by listing all the terms. So in set builder form, we will always provide a property which is satisfied only by the elements in the set and not by any element outside the set. And we denote the variable as the element, arbitrary element in the set. Also we denote x, here we usually we use x as the variable here, and we denote it as x such that x is a vowel in the alphabet. Or if we use the variable y, then we should name it as set of all y such that, we should read like that, set of all y such that y is a vowel in the English alphabet. You must read like this, set of all x such that 0 less than x less than 5. Set of all x such that 0 less than x less than 10,000 where x element of z. This is the way to read the set builder form. Now we shall do the example 1 of your textbook. The question is that write the solution set of the equation x square plus x minus 2 is equal to 0. So we have to write the solution set for the equation in roster form. It is specified in this question. So we have to write the solution set for this equation in roster form. We know that this equation can be splitted into x minus 1 into x plus 2 is equal to 0, isn't it? By splitting the middle term method, we can split it into x minus 1 into x plus 2 is equal to 0. Now, a product is equal to 0. This is of the form a into b is equal to 0. A product is equal to 0, which means that either x minus 1 is equal to 0 or x plus 2 is equal to 0, isn't it? Which means that x is equal to 1 or x is equal to minus 2 is the solution set. So 1 and minus 2 is the solution of this equation. So in order to represent it in the roster form, let me name that set as A, and in the roster form we can represent it as 1 minus 2 as the solution set of the elements or the solution set of the equation in roster form. So this is the answer for example 1 of your textbook. Now coming on to example 2 of your textbook, write the set. You are given with a set of all x such that x is a positive integer. X is a positive integer and x square less than 40. X square less than 40. So you have to write this set in roster form. Can you say which is the form used here to represent the set? Of course, it is set builder form. It is of the form x such that, and you are given with the property, and you have to build the entire set into the roster form. What is the property? X must be a positive integer. So the listing should start from 0, 1, 2 or 1, 2 etc. Right? And the next property is x square less than 40, isn't it? So you have to calculate or you have to list out all the positive integers with, let me name the set as A. So A is equal to, in roster form, 1 square is a positive integer and whose square is less than 40. So 1 is an element, not 1 square but 1 is an element. See, x such that x square must be less than 40. So the elements are basically x. Now considering the element 2 square is 4 which is less than 40, 2 is an element. 3 is similarly an element, 4 square 40 16, so it is also less than 40, and 5 square 25 less than 40, 6 square 36 less than 40. Now 7 square is 49, which is greater than 40. So our listing stops by this, and this will be the set in the roster form. So this set can be represented in the roster form like this. The third example is, write the set. You are given with a set in roster form. A is equal to, set A is equal to 1, 4, 9, 16, 25, etc. in set builder form. So you are asked to write the entire set. This is a set in roster form. So you are asked to write this set in the set builder form. So see, 1 is a perfect square, 1 square. 4 is again a perfect square, 2 square. 9, 3 square. 16, 4 square. 25, 5 square, and proceeding like this, which means that A can be represented in the set builder form as set of all x, such that x is a square of natural number, right? Square of natural number. See, unlike the previous example, here the elements are squares. So x must be a square of whose natural number, 1 square, 2 square, 3 square, 4 square, 5 square, etc. So this is the set builder form of this set. Coming on to example 4 of your textbook, the question is, write the set. You are given with a set in the roster form. Write the set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, and at the last 6 by 7. In the set builder form. So you are asked to write this set in the set builder form. This is a very interesting question. You can see that the specialty here, let me name this set A. So you are asked to write the set builder form for the set A. See, you can observe the specialty. The numerator is 1 less than the denominator. So we can directly write set of all x such that x is equal to, what is the form of x? Numerator must be 1 less than the denominator. So if the numerator is n, then the denominator must be n plus 1, right? So the form of this is n by n plus 1. Now you have to check. See, we named the numerator as n, and the variation of the numerator is from 1 to 6. So we should write 1 less than or equal to n less than or equal to 6. So this is the set builder form of this set. Very easy if you really able to read this set specifically. See, here the numerator is 1 less than the denominator, so we named our element as x, and the form of x is nothing but n by n plus 1. We named the numerator as n and the denominator as n plus 1, and the numerator can vary from 1 to 6, that is written here. So automatically the denominator will vary from 2 to 7. So since the denominator is nothing but n plus 1, and we return the variation of n, this is enough. So this is the set builder form of the given set in the roster form. Now we shall move on to the example number 5 of your textbook. Match each of the set on the left described in roster form with the same set on the right described in the set builder form. So you are given with 2 sets. From observation itself, you can see that all the sets in this side are in the roster form, and all the sets in this side are in the set builder form. Now we have to match that. Now we shall match the set builder form with the roster form. See, A is the x such that x is a positive integer and a divisor of 18. We shall check which satisfies that. See, in the third set we have these all are positive integers and all are divisors of 18. 1, 2, 3, 6, 9, 18, etc. All are divisors of 18, and no other set satisfy this property. So we can say that these two are the perfect match, right? Now coming on to the second set, x such that x is an integer and x square minus 9 equal to 0. See, x square minus 9 equal to 0 means x square equal to 9, x is equal to square root plus or minus 3. See, that means this set is actually plus 3 or minus 3. X is an integer and x square minus 9 must be equal to 0. From this set, we can see that the fourth one in roster form is nothing but 3 minus 3, which is a set satisfying this property. So we can match these two, isn't it? Now coming on to the third set. It is the set X such that x is an integer and x plus 1 is equal to 0. See, x plus 1 is equal to 0 means x plus 1 is equal to 1 here, x plus 1 is equal to 1 means x is equal to 1 minus 1 equal to 0. We shall evaluate which set satisfies that. See, the second one has only one element and that is 0, so it satisfies the third set. So we can match these two, isn't it? Now at the last, the fourth set is set full x such that x is the letter of the word principal. See, Principal is the letters in the word principal, and here we have a set of words Princical, and see that we are avoided all those words which repeated twice. We listed only once a word, and that is enough for the representation of a set. Whenever we have a repetition, no need to represent it again in the set. If it is appeared once in a set, and then that's enough. That is, നമുക്ക് ഒരു നമ്പർ അല്ലെങ്കിൽ ഒരു എലമെന്റ് ഒന്നിൽ കൂടുതൽ തവണയുണ്ട്, then no need to represent it over and over again. Just represent it once in a set. So we can say that these two are perfect match, and that's the end of example number 5. So that's for today's class. I hope you understood all these concepts we have discussed in the class. We have discussed what is a set and how we can denote a set, how we can represent a set. We can represent a set in two methods, and we have done several problems using this concept. In the next class, we shall solve exercise 11.1. So till then, bye bye.